This is the solution to problem number 8 from the spring exam of 2018. A ball is launched from the top of a tower at an initial velocity of 5 meters per second at 30 degrees off of the horizontal. The ball lands 10 meters from its starting point. We're asked to find what is h. The way to think about a problem like this, as always, is to break it into its components. The x component of this 5 meters per second is going to be a constant speed, and the ball is just going to continue at that speed, and it's going to keep going at that constant speed. There's no acceleration in the x direction until it hits the ground. Once it hits the ground, it can't go any further in x. In the y direction, there's negative acceleration due to gravity. So it starts out with a positive velocity going upwards, and then it's got a negative acceleration, and eventually it falls and hits the ground. The formula we're going to use is that the position is equal to the initial position plus the initial velocity times time plus 1/2 times the acceleration times time squared. Let's plug in the numbers for the x component. In our coordinate system, we're going to call this 0. The ball ends at position 10 meters. Its initial position is at 0 meters in the x direction, plus the x component of the velocity times time, and there's no acceleration in the x direction, so the 1/2 at squared term is equal to 0. We know that the x component of this velocity is 5 meters per second times cosine of 30. So we end up getting that 10 meters equals 5 cosine 30 times time. Now the time, as I mentioned, is how long the ball is in the air. We know that it keeps going at this velocity until it hits the ground. And so we don't know what this t is, but we can solve for it because we know everything else. We take the 10 meters, we divide it by the x component of the velocity, 5 cosine 30, and we get the airborne time. It has to be airborne for 2.31 seconds to make it 10 meters, given the x component of its velocity. Now, we just need to figure out what height the tower has to be at in order for it to be airborne for 2.31 seconds. So let's write out the y component of this equation. The final position in y is 0, and the initial position is at h. So 0 meters equals h plus the initial y velocity times t plus 1/2 at squared. We plug in the numbers. 0 equals h plus 5 sine 30, that's the y component, 5 meters per second times sine of 30, times t, minus 1/2, 9.8 meters per second squared, times t squared. The minus sign here is because the negative direction of the gravitational pull, it's going downwards. We plug in the numbers, and we know that it was airborne. It had to have been airborne for 2.31 seconds, and so we know it started at a height h, ended at 0, and we know how long it was airborne, so we plug in the times. 5 sine 30 times 2.31 minus 1/2, 9.8 times 2.31 squared, and when we solve for h, we get that h equals 20 meters, and that's the answer.